Welcome. We're doing it. This is question 4 from the 2015 AP Stats Free Response Test question. And when I see a question like this, I'm like, oh boy, they gave me lots of room to state, plan, do, conclude. I'm going to murder this question. So let's get to it. It says a researcher conducted a medical study to investigate whether a low-dose aspirin would reduce the chance of developing cancer. So let's think about what's happening here, folks. Somebody thinks if I take a pill, my chance of cancer goes down. Now, nobody likes cancer, okay? So if there was a pill to take that would reduce our chances of cancer, then people would take the pill. But people can't take the pill unless we prove whether or not it even works. And to do that, we have to use statistics. So let's get to it. It says, as part of this study, 1,000 adult volunteers, okay, so these are volunteers, were randomly assigned into one of two groups. So that's good. So we do have random assignment. So 500 went to one group, random assignment, 500 went to another group. And half of the volunteers were assigned to the experimental group, took the low-dose aspirin, and the other half will be called the control group, all right? Those people took a placebo, so I could call this placebo, or I could just call it the control group. Actually, the pill they took, low-dose aspirin, and the pill was a placebo, so I'm just going to call that PL. Now it states that at the end of the 6-year study, 15 of the people who took low-dose aspirin, so there was 500, so we're going to compare these results here. 15 out of the 500 had developed cancer, so that's the proportion of people that had cancer in the first group, and 26, so we're actually comparing these results here, 26 out of the people who took the placebo. And so we're like, aha, it works because I'm trying to get this number to go down because I'm trying not to get cancer. So success here is cancer, which sounds weird. But you get the point that we want this number to go down because we want to reduce our chance of getting cancer. Now it says at a significant level, alpha 0.05, which we would assume unless they told us otherwise, does the data provide convincing statistical evidence that taking this low-dose aspirin each day would in fact reduce? So it looks like we do have some amount of evidence, and we have to decide, well, what would be the probability of this happening if, in fact, this does have no effect? And if it's a rare enough outcome, less than 0.05, we do have statistical evidence that taking the low dose of aspirin each day would reduce the chance of developing colon cancer in similar volunteers. Okay, so the state box kills everybody. So let's go ahead. I have my setup here. And again, I need to establish an H sub O. And so ultimately, H sub O has to be that the two proportions are the same. Proportion 1 is the same as proportion 2. And yes is the proportion question. And then here we go, proportion. We have reason to believe a one-sided test here. We are hoping that the proportion of people from group 1 have something less. And we actually have some amount of evidence of that. Okay? Now we have to define P1 and P2. And if you don't, bad things happen. You don't get college credit. So let's do it. Let's define it. P1 is the proportion of people or volunteers who develop colon cancer from taking or after taking the low-dose aspirin. And let me give myself more room. What is proportion 2? Proportion 2 is the same thing, only slightly different. The proportion of those who develop colon cancer from taking the placebo. All right, so now we've set those out, and we should also calculate each one. So we know in the low dose aspirin group, P1, the proportion is 15 over 500, which is a proportion of 3%. So it's a pretty low percent. And the proportion 2, I got 26 out of 500, which is a slightly higher proportion. That would be 4, a little more than 4% of the people in the other group. But that could have been purely by randomness. So let's go ahead and test this out. So we end up getting to our plan here, and we need to do an R, an N, and an I, correct? So first we said we can say our plan is we will perform a 2-sample, because we do totally have a 2-sample, z-test for comparing these proportions. Now, if you have trouble coming up with this sentence, you would go to the calculator and you'd figure out, okay, I know I need to do a stat test because I'm not doing a confidence interval. And then these are my choices here. So we almost never pick Z. That's for quantitative if I have a standard deviation of the population. This is the same, but if I don't, 2-sample Z, those are still quantitative. So these are the categorical questions. Do you have cancer, yes or no? This is obviously the one we pick. And so we want to make sure that we call it the same thing, a 2-proportion z-test, or what I just did there. That would also be appropriate too. We will perform a 2-proportion z-test. Okay? Now that we've told them what test, we're going to tell them the conditions and whether or not those conditions have been met. So first, we look up here and we see that we have this random assignment. We read the word random. So we're going to say, because this is a random experiment, the condition has been met. Since treatment was randomly assigned. Okay. Now let's get into the N. So I'm looking at this here, and the second condition seems to be met. Because we got some super big numbers, right? Because the sample size is quite large, right? And ultimately, because this is a proportion question, we need at least 10 yeses and nos, and that's in both sets. So notice at least 10 yeses and nos. Condition met because the sample size is quite large, which resulted in at least 10 yeses and nos in both samples. 15 from proportion 1 from sample 1. 15 was greater than or equal to 10. And the difference of that, so 500 minus 15, which would be 485, is also greater than or equal to 1. And then in sample 2, 26 was greater than or equal to 10, and that number, 7, 4 is greater than or equal to 10. So again, therefore the condition is met because all are greater than or equal to 10. Last but not least, independence doesn't truly come up here because we sampled every person. And we have a test of volunteers. But if you made a statement here, independence assumed, they wouldn't have counted off for that. It's just, I think so it's safe to put independence assumed. We've now done the state and the plan. Stay tuned for the do conclude.